Hi, so we're going to wrap up section 3.2 on standard deviation. And what we're going to work on is population standard deviation. So for the sample standard deviation, we use the notation S as the sample standard deviation. But for the population standard deviation, we're going to use a lowercase Greek sigma, right? So it looks like this. Okay, so it's kind of like that. It's really good to get used to these words, these letters, because we're going to say them so many times in the course, and it will help you remember what's said when we refer to it. Okay, so the population standard deviation is calculated in a manner very similar to the sample standard deviation. One difference is when you divide not by the number of observations minus 1, but you divide by the number of observations. Okay, so I have the example from the notes. Susan scored on the 4 statistics tests the following grades: 60, 75, 80, and 65. I found her population mean, mu. I added them up and divide by 4, and the mean grade on Susan's test is a 70. Okay, and so what we want to do is we want to calculate, looking at the formula, the numerator is the sum of the x minus mu squared. We recognize x minus mu as those green bars, those deviants. So we're going to work here in this table form, and each of them, we'll calculate a deviant for each of the values that we have. So mu is 70. So 60 minus 70, we get minus 10. 75 minus 70, we get 5. 80 minus 70, we get 10. And 65 minus 70, we get minus 5. Notice that our deviance still sum to 0, and that's our check here, that we have calculated the deviance correctly. Okay, so we're going to go ahead and follow the formula. We're going to square the deviance, then we're going to add them up, and that will be our numerator. So minus 10 squared is 100, 5 squared is 25, 10 squared is 100, and 5 squared is 25. We add them all up, 250. Okay, and that's the numerator in my standard deviation calculation. So we'll go ahead and that's my numerator. Okay, so we'll go ahead and sigma squared is equal to my numerator, 250, divided by the number of observations. We get, that's 4, and I take the calculator out for this one, 250 divided by 4 is 62.5. And that's my sigma squared. So my sigma is going to be the square root of 62.5. And I get 7.9. And that's how far, on average, observations are from the mean. Let's look at it. 7.5, is it somewhere between the 10 and the 5? Those are those values for the deviance? Yes. So I think this is a correct calculation. 7.9. All right. So I want to go through what would happen to a standard deviation if each of the observations were changed by the same value. So in the case for the problem on the notes, what we have is if Susan receives 5 extra credit points for each test, find the standard deviation of the new tests, okay? By the way, in the notes, we refer to the word variance. It's not a word we're going to use a lot, but just so you know that the square of the standard deviation is called the variance. And then when you take the square root of the variance, you get the standard deviation. Okay, so let's say rather than the 60, Susan's getting a little bonus, like extra credit, or I'm not quite sure why she's getting 5 extra points on each of her tests, but 60 goes to 65, 70 goes, 5 goes to 80, 80 increases to 85, and 65 increases to 70. All right. Now, if you will, please take a minute and find the new mean. Maybe you don't even want to do that. Maybe you just want to guess what it is first. We took each observation and increased it by 5. So what do you think is happening to the mean of those observations? Okay, so take a moment and actually I'm just gonna do it. You guys will as well. If you already have a guess, good, write it down and then calculate it out. My new mean is I added all of these up and divided by 4, and my new mean is 75. So what happened? I increased each observation by 5, and then when I took the mean itself increased by 5. So what's going on is the measure of center kind of the observations all increased by 5, and so that measure of center, that balance point that we call the mean, that also increased by 5. So we're going to go ahead and we're going to look at what the first deviant is. So the first deviant is x minus mu, and in this case, that mu is 75. So we got 65 minus 75, and we end up with minus 10. Notice that what did we do? All right, we increased each observation by 5, and the mean increased by 5. So the deviation of this data point from the new mean, it's still exactly the same as the deviation of the original data point from the original mean. And now we can kind of go through this, right? We can subtract here. Subtract the 75 from each of these. If you want to, you can follow along. Maybe you already can guess what the standard deviation is going to be. All right, maybe you can. All right. So if that's the case, then write it down. Otherwise, I'm going to work on it right here. I'm going to be fast because I'm actually noticed what happened, that the square of each of the deviants is exactly the same. So this is exactly the same table as we had before we increased Susan's grades by 5. And so what we're going to end up with is that sigma squared is going to be 250 over 4, 62.5. And sigma is the square root of 62.5. And that means sigma is 7.9. So there is a takeaway moral here that I hope that you bring with you. And that is that if every value in a data set is increased or decreased by the same value, then the standard deviation remains unchanged. Remember, the definition of standard deviation, how far on average observations deviate or are from the mean. And you can see, if we're adding a constant to every number, the deviants don't change. All right, so that's it for section 3.2. I'll see you in the next video.